The equation x cubed minus x squared minus 5x is equal to 3 minus y squared implicitly defines the curve shown below. The line y equals the square root of 24, which is this line just here, intersects this curve as shown below. We can see just the one intersection just there. It can be shown that the equation x cubed minus x squared minus 5x plus 21 equals 0 will determine the intersection between the line y equals the square root of 24 and the implicitly defined curve. And that will just be by substituting the square root of 24 into here. Explain with reference to the graph above why we know that there is one real and two complex solutions, a conjugate pair, to this cubic equation. Well, the first thing to note is that it's a cubic equation. Then if you look at the coefficients, they're all real. So we have a cubic with real coefficients. We know for a cubic that there would be 3 roots, and we can only see one of them just here on the graph. Therefore, the other two must be complex, and because we have real coefficients, they must be as a conjugate pair. Determine the two exact complex solutions to the equation x cubed minus x squared minus 5x plus 21 is equal to 0. No, it's only 2 marks. I don't really need to show any working here. So I'm going to take advantage of the fact that it is a calculator paper. I'm going to go to main. I'm going to put myself in complex mode. I'm just going to clear anything that's on the calculator at the moment. And then I'm going to go action advanced solve. 0 equals, and we'll put in x cubed minus x squared minus 5x plus 21, and let's see what that gives us. So we've got x equals -3. I might make a note of that one just up here, and then we have x is equal to 2 plus or minus I root 3 as our other solutions. Calculate the area of the shaded region correct to 0.001 square units. So the shaded region is here. So we know that we can do that as the integral of y dx. And if we work out this top part, because of the symmetry, we can just double that. Now I'm going to start by rearranging the curve slightly to -y squared is equal to x cubed minus x squared minus 5x plus 3. So y squared is 3 plus 5x plus x squared minus x cubed. And that means that y is plus or minus the square root of 3 plus 5x plus x squared minus x cubed. And the plus or minus is just above and below. So what we can do for the area is we can do twice the integral from, now we need these points of intersection. Now we know on the x-axis y is 0, so what we can do is solve, substituting y equals 0 into the original equation. We've got x cubed minus x squared minus 5x is equal to 3. And that gives me -1 and 3. So this one's at -1, this one's at 3. So we'll go -1 to 3 of the square root of 3 plus 5x plus x squared minus x cubed dx. And we'll calculate that. So I've calculated that and it gives me 17.067 correct to the accuracy required.